All right, arithmetic. So yesterday we talked about sequences and series that we had to find the pattern, right? So we're going to talk about two kinds of sequences and series. We're going to talk about arithmetic and geometric, all right? And we're going to run through some scenarios with both of them. You have a sheet in front of you. You should see the top half is arithmetic, the bottom half is sequences and series, and then the first quarter is explicit, the second one is recursive. We're working strictly with explicit today, okay? So we'll be on the very first line there on your formulas. So arithmetic, what arithmetic means is that there's a common difference between terms. When I say difference, that means what? Add or subtract, right? Subtraction typically means difference. So there's a constant number that's being added to or subtracted from in arithmetic. Now geometric is going to be different because it's going to be a multiplied value. This is going to be an added or subtracted value. So for example, -4, 1, 6, 11, 16. The question is it arithmetic? Yes, because each time I'm adding 5, right? To get from one to the next, I have 5, and you have to make sure that you check every single term. Okay? Yes, you were, but we're going to use this to form an equation based on the term number itself, but we're going to use a formula to do it this time. Yes. Hmm? The difference would be -5. Essentially what you're doing is you're taking this term and you're subtracting the one before it. That's why it's a common difference. You're looking from term 2 to term 1 to see, and you're subtracting to see how you got there. That's why it's called a common difference. This is going to blow your mind. The variable we use to describe the difference, it's D. Okay. But like I said before, as you're finding it, if you're subtracting and you're using it like a difference, you have to do like second term minus first term. So when you're subtracting, it would be 16 minus 11, not 11 minus 16. It's what do you need to do to get to the next term. Okay. So that's your D. How about this one? 3, 5, 9, 15, 23. Is it arithmetic? Oh, that's a 15. The 5 decided to jump ship. Why? It's not right. There's a pattern. There's a definite pattern to it, but the difference is not constant between each term. Right? It's going up by 2, then it's going up by 4. Then it's going up by 6. So there's a pattern there as to how it's getting to the next term, but it's not arithmetic because it's not the same difference each time. Does that make sense to you? So there's a little formula and on your sheet. To find the rule for an arithmetic sequence. So you've already determined it's arithmetic. Here's how you do it. It's A sub n equals A sub 1. What would that mean, A sub 1? First term. First term plus that D that you found times n minus 1. So you're going to have a value here and a value here, but the n is going to stay. Remember when we were writing the rule 2n plus 3? Okay, all that would stay. Now to get it in that form, 2n plus 3, you'd have to distribute the D through the equation and simplify down, but this is easy. Writing the rule isn't. That'll give you the rule. But we're going to do several things with this. So we're going to do 3 scenarios. We're going to write a rule, and then we're going to write a rule. We're going to write a rule when we're given the entire sequence. We're going to write a rule when we're given one term and a difference, and then we're going to write one term. We're going to write a rule given just 2 terms from the sequence. Okay. So there's some different It gets a little harder as we go. What I'm getting at is don't shut down on me because this looks easy and it is, because we're gonna build on it, okay? All right, so scenario 1, write a rule given a sequence. 4, 9, 14, 19. Tell me what you should probably do first.
Find your difference.
Find your difference. Always find, bless you. Find your D. Okay. Plus 5. I know, we need another variable. What's the difference here? How am I getting from one term to the next?
Break a leg.
Plus 5 each time, right? All I'm going to do is plug in that formula. Remember that formula is A sub n equals first term. What's the first term? 4 plus the difference is 5 times n minus 1. I am a-okay with you leaving it right just like that. If you want to simplify it, yes. If you would like, is this easier than yesterday where you were finding the rule? If you do like to simplify it, you can. You could distribute that 5 through. You would find that a sub n equals 5n minus 1 because you'd have minus 5 and then add it to the 4 there. You do not have to. You can, for me, you can leave it, because if you do 4 plus 5n minus 5 and you combine like terms, negative 5 and 4 is negative 1.
For now.
Okay. All right, so I'm not going to do any more with scenario 1 unless you need it. Do you have a question? Okay. For what? We won't do those. We'll do that in a minute. That's series, not sequence. No, it's today, but it's after sequence. All right, scenario 2. 3, and then we do series. Okay. Let's write a rule. Write a rule given one term and the difference. So a little bit harder now. I'm not just plugging into the equation and being done with it, right? What if I told you that a sub 19 equals 48 and that the difference between each term is 3?
Oh, we have to find one?
I've got that right. Remember my equation is a sub n equals first term plus difference times n minus 1, right? I'm going to have everything except n. So I need the d and the a1, right? I already have d, so that's easy. Thank you, Corbin. So now I'm going to use the term given, given term to plug in and solve for the first term. Well, this is saying, all right, so understand what this is saying. This is saying that a sub n, so 48, equals first term plus 3 times, what would n be when it's 48? It's saying if you plug 19 into the equation, it should give you 48, right? That's the way it works. When you plug the n in, it spits out the term. So if I plug in 19, which I did, it better spit out 48. So now you have a linear equation that needs to be solved. That's easy peasy. It better be anyway. We're going to solve for A1. So,
Is that going to be 40?
What's 3 times 19?
no. 3 times 18.
She wrote 19.
Minus 1.
Minus 1.
You were thinking when there's a variable in the parentheses and you have to distribute through there. But since this was just numbers, we can simplify the parentheses first, then multiply. But you would not have been wrong, Kirkland. You could have done that. If I subtract 54 from both sides, what do you get? Negative 6. Now look, that's my A1, right? So what is my final equation? What's the first term? Plus 3, which is the difference, right? And minus 1. Scenario 3. This is the tough one. Write a rule given two terms. I'm going to do you some little steps on the side first. Bless you. Let's say, I'm going to use the examples out of the book so I know it comes out right. A sub 8 is 21 and A sub 27 is 97. Okay. Now remember in my formula, there are two things I need. I need to find the first term and the difference, right? We can easily find the difference between this, and if you think about it, it makes sense. Go ahead, what do you think you do? No. Let's say, I know you can. Let's say I had this length of whatever this ruler is here, and I told you that, how can I say this right? How would you find the length between 97 and 21? You would subtract them, and if you know that one of them is in the 8th spot and one of them is in the 27th spot, could you find how much distance is between each one? How? Divided by how many possible spots there are, right? You take the total length, so I'm thinking 21 to 97 would be, if I subtract, I can find the total length, right? Right. And if I divide that by how many spots I need 27 minus 8 different terms in between. That will tell me how much distance is between each spot. So you can do this every time. 76 over what? A sub 8 is 20. What's it come out to be? What's your D come out to be?
27 minus 8.
What?
Oh my goodness. That's what I get for using an example out of the book, and I was like, but I used the same example and they got a D of like 7 and they didn't. I was looking at it wrong. Okay, over what's this give you? 27 minus 19, which reduces down to 4. Okay. So if you subtract in general terms, a little more general terms, subtract the terms and divide them by the difference of the term numbers themselves. It'll give you the difference, okay? So now I'm back to scenario 2. I've got difference, and I can pick either one of these to use to plug in. Huh? Smallest, I would too.
So you take those two and give them one D.
Yes.
Wait, so that's the only thing that's different than scenario number 2.
Yes.
So it's not that bad.
So you have to calculate D for this one
Yeah.
instead of it just being give to you. Right. All right. I'm going to use, everybody said the first one. So if I plug 8 in for n, the equation better give me 21. So 21 needs to equal first term plus 4 times 8 minus 1, right? So 21 equals first term plus 4 times 7 is 28. That's right. Move that 28 over.
Class leaving?
Why? Right. They solve it a different way in the book.
Wasn't 4 times 8
But you do 8 minus 1.
Oh, so then it's 7 times 4. I'm combining it.
Okay, good. Fine. I got it.
Make sure you pick up the series part of the video. Yeah.
I'm so sorry.
Good luck in your play.
Yeah.
This is probably the easiest sum of a series you'll see. This is a little formula so that you don't have to calculate each one added together and do it, because what if you had 100 terms or 1,000 terms you needed to sum? Yes.
I don't like the number of that.
It's pretty short.
So is it
Maybe
this?
not.
Is it
That's good. That should be
Are we
good.
using this paper?
90% sure.
Is there going to be,
All right.
is there,
You will have this half sheet on your test, as well as your exam. All right, so tell me the difference again in a sequence and a series. Series adds, right? We're talking summation notation here. Let's say I asked you to find the sum of 2 plus 7i from I equals 1 to 12. Now, I could plug in, if I so chose to, I could plug in, right, from 1 to 12. But if you recognize that this is arithmetic, and how do I recognize that it's arithmetic? It's a number times the variable, right? It's just some number times that. And you can add or subtract something. You don't have to, but you can, okay? There's no variable in the exponent or anything crazy like that. There's no fraction that I'm dividing by a variable. Nothing like, it's just, it's in the same form. It's in the same form that we've been, the a sub 1 plus d times n minus 1. If you simplify that out, it's in the same form, right? So look at that little formula, s sub n. S sub n equals n times a sub 1 plus a sub n over 2. Now, I will caution you, make a note on your sheet. A sub 1, it's used there kind of loosely. It's really first term. And normally you would start with 1, but if this said sum it from I equals 0 to 12, then a sub 0 would be your first term. You see what I'm saying? Most time we're going to start with term 1, but some series start with term 0. So it'll make a little bit of a difference. All right, n. N is going to be the number of terms that you're summing. And a sub n is your, if a sub 1 is your first term, what do you think a sub n is? Last term. So essentially what you're doing is you're averaging the first term and the last term together, and then you're multiplying by how many terms you have. Okay, so it's a pretty easy concept. No, this is only for finite arithmetic, yeah. Now we will sum some geometric series, some infinite geometric series, but only some of them will sum. Yes. All right. This is it. This is the last thing. All right, so my question to you is...
But there's not like special like scenarios.
No, not this. The most special scenario will be if you don't start at 1, maybe you start at 5 or you start at 0. This just means first term, yeah. And then you just have to be careful to count. If you start at 0 and you go from 0 to 12, that's actually 13 terms instead of 12 terms, right? Does that make sense? All right, so how many terms do I have here from 1 to 12? 12. Times, what's the first term? What is it? 9.
Oh, you plug it.
Plug 1 in, so 2 plus 7 is 9. What's the last term? 86. Divided by 2.
That's going to be a
Last term is if you plug 12 in here for I. So 7 times 12 is 84, plus 2 is 86. That's okay.
What is SM?
The sum of the series. 9 plus 86 would be 95 over 2, which is going to be 6 times 95, which is what? I don't know. 30, carry your 3, 55, 70?
Yeah.
I just did it in my head instead of using my calculator. Does that make sense? You would just plug that on your calculator. Don't make it harder than it is for sure.